Well, thank you very much for having me here today. I wanted to just begin quickly by giving you a little bit of insight as to why I actually think that reviving waste, bringing it back to life, is the way of the future. We talk about recycling, so I'll tell you a little bit about what it actually means, how do we redefine our whole thinking around recycling, and it is to do with bringing waste back to life. So let's just try and understand why this is so important. I mean, we all are creatures of our products and everything that we need to use, our electronic goods, the cars, the materials that we have in our day-to-day lives, the basics, the clothing, the footwear, and the list goes on. And of course, it's exciting. We all love it. But I think the real challenge that it creates, which I find actually equally exciting, is how do we then take the waste that it has created and in fact convert that into a resource so we don't in fact have this negative impact on our environment? Can we actually do that? Can we actually achieve this utopia where we can still sort of go on, we depend upon our material goods, but can we also do it without having this negative impact? And hopefully one day we'll get there. We will absolutely get there. In fact, the whole notion of using waste and looking at the value in it always excited me. In a place like Mumbai where I grew up, it was always an exciting sort of fact that someone would actually come around and give you some money for all those empty bottles that you could in fact collect. So for me, it didn't matter if it was all you'd get was 5 paisa, it was 5p, and that's what was important to me. So suddenly this notion of waste connected to value was very exciting. So if you could in fact attach some value to it, why would you waste the waste? Can we actually get to the stage where nothing is in fact considered a waste? Well, of course, we all do our bit about recycling, and the whole conventional notion of taking plastic, converting it to plastic, the notion of taking a product like glass and converting it into glass and steel into steel and so on, and we're all familiar with that. So what about those scenarios where we still have a problem, where we still produce so much of waste that ends up in landfill? The reality is that these types of materials are so complex, and we need to understand and respect those. But equally importantly, if we could find a way to use these types of resources as valuable raw materials, as valuable inputs, and if we could reconceive them as raw materials to manufacture completely different types of products, then in fact we would be in a situation where actually nothing would be considered a waste. It would in fact be such that everything could be seen as a valuable raw material, as a valuable starting point for something else. So we could imagine a scenario where in fact a product could end its life in one form, in one shape, and of course go on to become something completely different. Well, how do you actually do that? If we could do that though, we would never really waste anything. So in fact, let's have a look at why waste is so complex. Yes, if you look at something that we're all familiar with, a car. Of course, in there, at the end of its life, a car, the steel is recycled and it's converted into new steel, and that's all great. But just think for a moment, what else do you have in there other than steel is you've got a whole bunch of different types of plastics. All part of our daily life. I'm using plastic as an example because whether it's an industrial product or whether it's something that we touch in our daily lives or something we just use at home, the reality is that that is part of the challenge. We all love to use it. It's great. It's convenient. And we really can't live without it. I mean, the fact of matter is that even in something like a car, we've got huge amounts of these materials that are present. At the end of its life, the steel's recycled. The mixtures of different kinds of plastics that are present in these types of automotive components, they all end up in landfill. Why is that? Because it's a complex mixture. It's not just a straightforward thing of saying, well, we'll just take this plastic, recycle it back as another plastic. You simply can't do that economically because of the fact that it's a complex mixture. So how do we actually deal with this problem? I mean, if you can't sort of think about that conventional notion of recycling, could we actually think of it as at the core of it, the basic elements that are present in these types of materials? And if you ask, well, what are the basic elements that are present? And how could we then reconfigure and use those raw materials to make something completely different? And here's a wild thought. If we could say, right, all of that waste plastics, if we could actually use that and make steel out of it. Now, I'm sure you're probably sitting there thinking, hang on, plastic, steel, they're nothing like each other. How on earth could you possibly ever get to that point where you're starting to use a waste coming out of, plastic looks different to steel. I mean, you look at it in cars, right? You've got steel and you've got plastics, and if I put the two together, they're completely different. What's she on about? The reality is that at the core of some of these types of materials, and I'll come to that a little bit later, what is present at the elemental level is what we need to look at. We need to look at how we might be able to break it down at that absolute basic level. And in fact, the fact is that between these two materials, however unlikely a match they seem to be, the reality is that there are common elements. So in fact, all I can say is when they're cold at room temperature conditions, they look like they don't even want to react and talk to each other. So how could you use one in the process of making, how could you use plastic in the process of making steel? Let me just tell you a little secret. That's when things are cold at room temperatures. This is what we're all used to. You start to heat up these things at high temperatures. Things get really hot and heavy now. That's when actually the chemical reactions start to happen. So from the point of view of looking at it as a materials engineer, it's very exciting because you can say, well, right, okay, that means if I can start to change conditions under which I react these materials, I could actually look at a whole range of different scenarios and possibilities. And I'll come to that in a minute as to how we've managed to achieve that in the context of these types of materials. Another interesting example, of course, that we all are used to is rubber tires, right? Whether it's tires coming out of cars or trucks or planes for that matter, right? It's all there in the wheels of it. This beautiful picture, of course, illustrates that, we have lots of it all over the world. How do we possibly take something like this, which is a resource, and notice I want to start calling it as a resource because it is a resource after all. It's too good to be thrown away, but how do we actually find a way to use this type of waste resource and put it into a manufacturing process where it actually becomes something value added? I mean, is it at all possible that we can have green technologies that are going to be good for the environment and are going to lead to better economic outcomes? I mean, I know it sort of sounds all very much that sort of thing of, yes, it's all nice to do. The reality is, I'll give you an example of one technology that actually shows that it is possible. That means we're starting down this journey where we can start to look at development of technologies, bringing together a whole range of different opportunities within the manufacturing sector. And certainly the example that I will give you is the world's first that has been developed right here in Australia, and we have now implemented it to actually demonstrate that, yes, on a commercial scale, this is very much possible. So let me use the example of rubber tires and tell you how indeed we can achieve that. We basically have used it in the process of making steel, and you might say, well, really, I mean, how do you use it in the process of making steel? And worst of all, what's a cappuccino got to do with steel making again? So, here we go with all these weird sort of connections. The reality is that in the process of making steel, when you've got all of these amazing liquids that are present at high temperatures, so you can see in the picture where it's glowing hot, it's more than 1500 degrees centigrade. So remember, I promised you that there is a scenario at high temperature conditions where this actually becomes quite a valuable raw material. And I'll just start to play this example here where I'm starting to compare the situation where, of course, traditional materials, and it's a coal-based material that's used in this process. So you might say, well, that's all good. What's happening here is you've got, at high temperatures, chemical reaction that's taking place. So the base that is sitting there is, in fact, a coal-based material, very much conventional technology. That's normal practice. And you might say, okay, well, it's all very sort of, boring old steel-making process. Why are you showing us all of this? If you now go back and say, well, actually, if this is what's happening with coal-based carbon, could we look at these alternative resources like that of rubber tires, which do contain carbon, and can we actually use that in the process of making steel? Hey, you know, look at what we've got to compare it against. You know, the performance is okay. It's not all of that crash hot. So let's look at what happens when we actually introduce some amount of rubber, in fact, in the blend. So now we've started to bring along rubber, and we've said this is a waste. Same conditions, same temperature, same scenario of reactions. And what actually gave us enormous joy out of looking at all of these types of situations where high temperature reactions were occurring, one, it showed us straight away, is that the chemical reactions in this instance were actually much, much more effective. You can see that this thing almost has a mind of its own. It was starting to react, and it was actually telling us something even before the data had been analyzed, that we're now sitting in a whole different regime where waste doesn't have to be thought of as a waste. We could actually introduce things like waste rubber tires into a steelmaking process and achieve much better outcomes. So of course, we knew that we were doing the right thing for the environment, but the fact that it can in fact give you a better process and better efficient process out of using these types of materials is a great win. Of course, I'll come back to it in just a minute when I'll tell you how many different tires we have, in fact, recycled in this process. Now, another aspect, as I was mentioning to you earlier, that if you're actually making steel, steel needs, under liquid conditions, remember I said more than 1500 degrees Celsius, it needs iron and carbon's an important alloying addition. So we said, right, okay, well, let's see if we avoid using coal-based materials. And if we just took plastics, again, a lot of these types of waste materials contain the critical ingredient that we need in the process of making steel, such as carbon. And what are you doing? Quite simply, you're dissolving that carbon into liquid steel. So these are high temperatures. Carbon is actually becoming part of the liquid steel, and you're making that end product. As far as liquid steel is concerned, it doesn't matter where that carbon came from. If it came from waste, if it came from coal-based carbon, doesn't matter. As long as the end product meets the specifications, you still achieved the right kind of outcome. The difference here is you created a whole nother possibility of actually using waste resources as input into the manufacturing process. So here we've demonstrated a couple of examples of how all of these things work in the lab, and that's all very fascinating. So you might say, well, that's all good. Works in the lab, fantastic. Do we actually have an example of whether this can be possible in a real steelmaking environment? And the short answer to that question is yes, it can be. In fact, we've now taken this concept, and it's the world first in terms of applying this innovative idea into a commercial practice, and that's happened at One Steel. But it also equally importantly showed us that it wasn't just about recycling the waste, but demonstrating the potential opportunities that we have, where we don't have to think of it as a bad thing, as something that's not necessarily going to give us good outcomes. In fact, quite the contrary. It ended up demonstrating that by using this type of waste resource, we actually were able to get better performance out of this material. So, I mean, who says it's a waste? Well, let's call it a waste, but let's remember that it's a waste resource. And in fact, here's an example of how you can use these types of waste resources and put it into a completely different application, which means at the end of the day, there's no limit to how we reuse and how we, in fact, reconceive these types of materials as input materials for manufacturing processes. And the fact that we can take the science out of the labs and put that out into manufacturing technologies in the real world just tells us, yes, there are a whole range of possible scenarios that we haven't even started to think about, where we can take waste resources and we can actually put that into real practice as very real raw materials, not just the token thing of recycling waste, but really thinking about it as a viable raw material that has got amazing outcomes. So at the end of the day, where are we headed to in all of this? Can we really ever get to that point where we are looking at a future which is a zero waste future? Can we actually look at a whole range of different products that we are using in our day-to-day lives, whether it's using equipment, sporting equipment that needs to be of special strength, or whether we've got fabric materials with certain properties. It doesn't matter. The question is, can we actually imagine that we can reconceive a lot of our waste materials as valuable raw materials? And I certainly do believe that the future is there, just ready for us to take it on, where we can in fact see a zero waste future, where we are looking at giving new life to waste materials, bringing it back up to life, looking at it as a viable alternative in the future, and really looking at not talking about end-of-life disposal, which is what we've been talking about. It's really now the future is saying, well, let's talk about how we might be able to do end-of-life revival. That's putting new life into these types of materials, so nothing is a waste and everything is a resource. Thank you very much.